Hello everyone, you are welcome to this channel of Nepali Online Math Teachers. The objectives of this video is to show to integrate a proper rational function by first expressing it as a sum of its partial fractions. Learner will have four learning outcomes at the end of this video. First, learner can find the integration of distinct linear factors. Second, repeated linear factors. Third, distinct irreducible quadratic factors. And fourth, repeated irreducible quadratic factors. Okay, let's begin. Okay, first, distinct linear factors. If the denominator of the fraction is given as x, x plus a, x plus b, then its partial fraction partial fraction is a over x plus b over x plus a plus c over x plus b. Now let's take an example. Yeah, you can see here in the question, integration of 4x square minus 14x minus 6 over x cube minus 2x square minus 3x dot dx. How we compute the integration such type of fractions? For this, we can use the concept of distinct linear factor partial fraction methods. That is, we have here, first of all, remove the integration part, only take the fractions and compute the partial fractions. Okay, this is our questions, and what we can do here, we can factor of this denominator. Okay, we can factor of this denominator and keep constant of this denominator up to the end, so up to here. So only from the denominator I factor here. I use the basic algebraic concept to factorization of this denominator. Then finally I have x times x minus 3 and x plus 1. Okay. Now the second process is I have to reduce this term into the partial fractions. Convert into partial fraction. What is that? That is, denominator keep constant 4x square minus 14x minus 6, and denominator also keep constant x minus 3 x plus 1 is equal to, in term of the partial fractions, a over x plus b over x minus 3 plus c over x plus 1. Okay, now take the LCM from the right hand side. We'll have x minus 3 x plus 1. Then this x and this x cancels. A times x minus 3 x plus 1 plus x minus 3 and x minus 3 are cancelled. So we'll have b times x and x plus 1 and plus c. This x plus 1 and x plus 1 cancel. Left c times x minus 3. Okay, and here in the left hand side, 4x square minus 14x minus 6 and x minus 3 x plus 1. You can see here this part and this part are same, so these are cancelled. So only we have 4x square minus 14x minus 6 is equal to a x minus 3 x plus 1 plus bx x plus 1 plus cx x minus 3. Now let's make 0. You can make 0 from x minus 3 as well, or from x plus 1 as well, no problem. So if you put here the value of x is at the beginning, if you put here the value of x is 0, then you will have all this part is 0. So if x is equal to 0 at the beginning, then we will have, that is a minus 0 minus 3 minus 3, 1 minus 3 minus 3a. Okay, then how much we have left in left hand side? This is 0, 0 minus 6. Minus and minus are cancelled. Therefore, a is 2. Similarly, when x is equal to, if x is equal to, when we put here minus 1, then we will have 0 from here. What is the result? Implies that 4 plus 14 minus 6 is equal to, implies that 4 plus 14, 18, 18 minus 6, 12 is equal to 4 times c. That is c is equal to 3. Okay. Again, when x is equal to 3, we have to put the value of x in this equation. Then 36 minus 42 minus 6 is equal to 12b. Therefore, b is equal to minus 1. This is also 12. Finally, we'll have a is equal to 2, b is equal to minus 1, and c is equal to 3. Now, what we are doing, we are using this value in this equation. In our question form, what we have, integration of 4x square minus 14x minus 6 over x times x minus 3 x plus 1 e dot dx is equal to, we can rewrite it as a over x plus b over x minus 3 plus c over x plus 1 dot dx. Now substitute the value of a, b, c respectively over here. Then we will have integration of the value of a is 2 over x plus the value of b is minus 1. So I can write here minus 1 over x minus 3 and plus the value of c is 3 over x plus 1 dot dx. Now separate these integrations, that is integration 2 over dot dot dx minus integration 1 over x minus 3 dot dx plus integration 3 over x plus 1 dot dx. Then finally we'll have 2 integration 1 over x dot dx minus integration 1 over x minus 3 dot dx plus, we can take constant as in front of this integration, so 1 over x plus 1 dot dx here. Now we can use here the formula of integration, that is ln x minus ln x minus 3, okay, plus 3 ln x plus 1 and a single constant here. So this is the solution. Now let's take repeated linear factor case. If we have the case of denominator is x minus b whole square, then we can take it as, for the partial fraction is a over x minus b plus b over x minus b square. Okay, for an example here I have a questions, integration 6x square plus 13x plus 6, and in denominator x plus 2 x plus 1 whole square dot dx. That is, we can rewrite integration of 6x square plus 13x plus 6 whole over x plus 2 x plus 1 whole square dot dx is into the form of integration bracket a over x plus 2 plus b over x plus 1 plus c over x plus 1 whole square dot dx. Check only 6x square plus 13x plus 6 over x plus 2 times whole square of x plus 1 whole square is equal to a over x plus 2 plus b over x plus 1 plus c over whole square of x plus 1. Take the LCM from the denominator from right hand side, then x plus 2 and x plus 2 are cancelled. Then a times whole square of x plus 1 plus b times x plus 2 times x plus 1 plus c times x plus 2. Now you can see here this denominator and this denominator are cancelled. Now we have left 6x square plus 13x plus 6 is equal to ax plus 1 square plus bx plus 2 times x plus 1 plus cx plus 2. Okay. If x is equal to minus 1, then what happened? Now let's see here. If x is equal to minus 1 here, if the value of x is equal to minus 1, then the whole equation gives us a is equal to minus 4. You can just pause this video and calculate the value of a, then you will have a is equal to minus 4. If the value of x is equal to minus 2, then the value of c we will have at the end minus 1. If the value of x is 0, then we'll have b is equal to 2. You can solve here on the similar way I do here. Okay, you just pause the video and solve this equation, then finally you will have these two values. By taking these questions, we'll have integrations of a over x plus 2 plus b over x plus 1 plus c over whole square of x plus 1 dot dx, which is integrations. The value of a is 4, b is 2 and c is equal to minus 1. The value of a is 4 over x plus 2 plus 2 over x plus 1 minus 1 over x plus 1 whole square. Now use the distributive property. That means we give the integrations to all this term. That is integrations 4 over x plus 2 dot dx plus integration 2 over x plus 1 dot dx minus integration 1 over whole square of x plus 1 dot dx. I'm using here the simple concept of integrations. That is, so finally the integration of the given function, this one, okay, integration of this function is, that's the answer. Similarly, distinct irreducible quadratic factors, when we'll have the denominator of the factor is in the form of quadratic equation, that is ax square plus bx plus c, then the partial fraction become ax plus b over ax square plus bx plus c, and the process of simplification is same as above. And let's move to the fourth concept. And the fourth concept is repeated irreducible quadratic fractions. For that is, if the denominator is ax square plus bx plus c is in the form of power, then we will have the partial fraction is ax plus b over ax square plus bx plus c plus. Now we can use the another same fraction into this term, that is cx plus d whole over ax square plus bx plus c power is 2. And this way we can solve such type of problems. Okay friends, here is the self-practice questions for you. Hope you can solve and find out the answers. Okay, so thank you very much for watching. Bye.